Hello everybody, and welcome to the next video on functions. In this video, I don't want to introduce any new concepts with functions or anything like that. We will see some more concepts as we move forward. In this video, I simply want to give you some more examples of functions, and the purpose is hopefully to get you more comfortable with using them. So here are three examples I want to show you. A function that calculates the largest of three numbers, a function that calculates a Borda winner for a three-candidate election. If you have forgotten what this means, recall that you already did a homework problem that calculated a Borda winner. That homework problem, of course, was entirely inside of main, but you have done this task already. You just haven't done it with a function, or anyway, a non-main function. And then finally, a function that tests whether or not a whole number is prime. So I'm just going to walk through these three examples and point out some things about them. And hopefully by the end of this video, you are somewhat more comfortable with using functions. And again, let me just issue the disclaimer that functions are difficult. They take some getting used to. You simply must be willing to play with them, to mess around with them. You just must be willing to speak with them until you are comfortable with them. So let me just re-emphasize, C++ is a language. Like any language, it's hard to speak at first. You simply must keep trying to speak it until you are comfortable with it. Okay, so let's start with a function that calculates the largest of three numbers. So before I write the function, let's think about what does that even look like? Well, recall here the declaration of a function. To even create a function, to declare it, you have to think about the data type of what you want to give back. Okay, so if the function returns something, if it outputs something back to you, you have to figure out what kind of thing that is. You must give the function a name, and then you have to tell the function a bunch of parameters. So you have to tell the function how many things you are going to feed into it and what kind of things those are. So if we're talking about the largest of three numbers, let's just assume these are integer numbers. Okay, it doesn't say that, but let's just assume that. Then how would this function work? In order for this function to do its job, you of course must hand it the three numbers you are interested in. If you don't hand this function three numbers, what is it supposed to do, right? So the parameter list should consist of three integers. You are going to give this function three integers. What kind of thing is this function going to hand back? Well, if you give it three integers, it's going to give you the largest of those integers back. So it's going to return an integer to you. In other words, the largest of three integers is again an integer. And then beyond that, we simply must give it a name. So we can call it, largest. And now we have thought through everything here. We know it's going to return an integer. We're going to call it largest. And we're going to have to hand this function three integers. So let me now go to the compiler, and as I did in the last video, I start by declaring things up top. So here's where I'm going to declare the function. It returns an integer. I'm going to call it largest, and then I have to hand it three integers. Oops. Okay, so when you actually build the function down beneath main, what does it look like? Let me just give some space down here so it doesn't crowd me. Okay, so what does this function look like? Well, you're going to hand the function in main three different numbers. And who knows if they are in order or not, right? But you're going to hand it a number that then becomes A, a number that then becomes B, a number that then becomes C. We need to return either A or B or C based on what the biggest is. So we can just march through all the cases here. So consider something like this. If A is what? Greater than or equal to B. Oh, and also A is bigger than or equal to C. Well, that means A was the biggest. So we'll return A. Otherwise, if B bigger than or equal to A, B bigger than or equal to C, what does that mean? That means B is the biggest. So we should give that guy back. And if either of those two things fail, we'll have to return C. So in other words, either A is the biggest, or B is the biggest, or C is the biggest, right? So the catch-all return at the end there, this else, A failed to be the biggest, B failed to be the biggest, so therefore C must have been the biggest. So back up here in main, let me just see if this works. I'm going to ask this function, hey, what's the largest of 4, 7, negative 2? And let's just see what it prints. It prints 7. Well, that's good because 7 is the largest of these three numbers. So let's just walk through again what's happening here. When you type largest, you have to hand it three things. In this case, I handed it just raw numbers. I could have handed it variables also. What happens here? This 4 gets passed to A, so A takes on value 4. This 7 gets passed to B, so that B takes on value 7. This negative 2 gets passed to variable C, and therefore C has value negative 2. So first we check, hey, is 4 bigger than or equal to 7? And is also 4 bigger than or equal to negative 2? Well, of course, this first statement is false, So we don't go into that if block. Instead, we go into this else if, right? 7 is indeed bigger than or equal to 4. 7 is also bigger than or equal to negative 2, so it was the biggest of the list of 3. So what gets returned is B. And recall, B has value 7. So what gets returned is an integer, and you can print to the screen integers. So the cout statement, the computer understands that. So you are literally telling the computer, print to the screen for me the largest of 4, 7, negative 2, and it does. So just to confirm that this works with variables also, let me just do x equals 5, y equals negative 6, z equals 8. So now I can do, what's the largest of x, y, and z? Computer, what do you think about that? So again, what happens here is the value of x here, x has value 5, that gets passed on to this variable a. So again, from the last video, these variables here are just kind of like placeholders. Like these are just names given to anything that could be passed into this. So the value of x gets passed to a, so a takes on the role of x here. The value of negative 6, which is y, gets passed on to b, so b takes on the role of y here. And then finally for c, the value of z is 8, so that value of 8 gets passed on to c, so C takes on value 8. So what should happen here is we check if 5 is bigger than or equal to negative 6 and also 8. That's false. Negative 6 is, of course, not bigger than either of them. So what should happen is we return C, and that's what value this is now. The return value is 8, or it should be 8. And that's what the computer prints, an 8. Okay, so before I move on, let's again just remind ourselves what's happening here. Whenever you call a function in main like this, you are jumping. You're jumping down here and doing this stuff. And the way that you hand the function your parameters is just you've given them names in main, either x, y, or z, or you could have done 5, negative 6, 8. Those values all flow down here. They get passed down here. Then the function does whatever it is you've told it to do. And when the function is done running, you can read off the largest back up here in main. So you're jumping, right? You start here. Then, of course, the computer works from top to bottom. So then the next line of code it sees is this. So it says, oh, I'm supposed to print something, but the thing I'm supposed to print requires this function. So I shall leap down here, and the value of x, y, and z all flow down to become the values of a, b, and c. Then I do all this stuff. Then I'm back up here in main, and I keep going. Okay. So let's next do the Borda winner calculation here. So what would this function look like? What do you need in order to calculate a Borda winner? Well, what you need is the election data, right? You simply cannot compute the winner of an election unless you know what the election looked like, right? You need the vote totals. So just like your homework problem from class, there are 6 different vote totals of interest. So if the 3 candidates are labeled A, B, and C, You need to know the number of people that voted A, B, C in that order. So A first, B second, C third. You also need to know the number of people that do A, C, B, etc. So again, just remind yourself of that homework problem. So all of that to say, when you build the function, what you have to hand the function is 6 numbers for the 6 possible vote totals. That's what the function needs in order to do its job. You can call the function whatever you want, like say board a winner, whatever. What does this function give back to you when it's done? Well, it gives you back the winner, right? And the winner we've either labeled as A, B, or C. So what this function gives back to you is a character, I suppose, right? Or if you want to think of it as a string, you could. But it gives back to you either the letter A, the letter B, or the letter C. Okay, so let me just build that here in main. Let me get rid of this just for space. Okay, so character, board a winner. And then what do I have to hand to it? Well, it needs 6 numbers for the 6 possible vote totals. So these 6 parameters are what the function needs to do its job. Okay, so once you've declared it up top, you actually build the function. You teach the function what to do down below. Okay, so what I'm going to do now is just steal one of you guys' homeworks. And let's see. Okay, right here. So I'm not going to name names here, but this was somebody whose homework was correct. I think most of your homework was correct. So before this function runs, let's just grab these vote totals, right? What's your vote total? D. What's your vote total? E. Whatever, right? So this person has labeled the 6 vote totals as D, E, F, G, H, I, right? So then in main, what you would like to do is something like this. Okay, here's your winner. I guess I should say board a winner. Here's the person who got the most points according to the board a schematic. And you would just say board a winner, and you would just plug these vote totals in. D, E, F, G, H, I. Okay, so in other words, what are you saying? You're saying, well, I'm going to hand this function these 6 vote totals. It's going to give back to me the winner of the election. So who is your board a winner? Well, it's the board a winner, when the vote totals are these 6 values. So down here, now I have to take these vote totals and give a winner back. Okay, so what I'm now going to do is just copy and paste this code. So this person's homework, they used what? D, E, F, G, H, I, right? And then I have decided to use A, B, C, D, E, F down here. So as you may have noticed, right, it doesn't matter if these letters match these letters, the values get passed. So whatever value D has gets passed to A, whatever value E has gets passed to B, etc. So A takes on the role of D, B takes on the role of E, etc. But you don't need a name match here. Okay, so all of that to say, what I'm going to do down here is just mimic this exact code here. So I have like a int A total, B total, and C total, right? The number of points per candidate. And how many points does A get? A gets what? Let me just copy and paste this. Okay, so right here, this is A total, B total, C total. Okay. Now the computer doesn't know what D, E, F, G, H, and I are down here because we're inside of a different function. These variables live inside of main, these D, E, F, G, H, I. So once you leave main, the computer has no idea what you're talking about when you say D. So what's happening inside this function is A is playing the role of D, B is playing the role of E, etc. So I'm just going to change all these. A, B, C, D, E, F. Okay. A, B, C, D, E, F, and finally here, A, B, C, D, E, F. And there you go. So again, what happened here was you grabbed a number D that corresponded to ABC's vote total. You then took whatever that value was for D and you overlaid it on top of A. So down here, A is playing the role of D, and that's why down here you can say that the total of A, you start with that first number, that's the first column in the table, 3 points for A for all of those guys, then 3 points for A in the second column, 2 points for A in the third column, etc. Okay, so now let me just grab all this code. And let's just assume there's a unique winner. Okay, so because here, notice this person has dealt with a case of a tie, right, which you had to in your homework. So if A total equals B total, and also A total is bigger than C total, then there was a tie between A and B. So notice the way I've set up this function. You can only return a single character. You can only give one winner back. Okay. So you may want to think about, if you want to, how you could return 2 winners, but this function can't do that. This function returns a single character. So all I'm going to do is tweak this to, in the case of a tie, just return a single character. I'll just arbitrarily let A be the winner or something. Okay, so if A total bigger than B total and A total bigger than C total, what does that mean? That means A won. So instead of printing down here, you don't have to print. Just give back that character, right? A was the winner, so give that character back. So way back up here in main, if candidate A was the winner, this entire expression now is just the character A, and that's what you will print to the screen. Right? Board a winner of this stuff, the output is the character A. That all becomes A. Okay, so if B total bigger than A total, oh, and also B's total bigger than C's total, what does that mean? That means the winner is B, so I would just give that back. And again, you don't need to print anything. Printing occurs back up in main. This function doesn't have to print anything, right? You're printing the result back up here. So if you also print inside the function, you're going to print twice. You'll print once in the function and then once back up here in main. So you're double printing to the screen. You don't need that. Okay, else if C total bigger than A total, C total also bigger than B total, then the winner is C. Okay, so here now, if A's total equals B's total, and A's total is bigger than C's total, what does that mean? There's a tie between A and B, and as I just said, we can't return both A and B, right? This is just a character function. That means it returns a single character. So again, you could think about how to return 2 characters, but I'm just going to arbitrarily declare A the winner here. You could, if you wanted to, write code right here that say flipped a coin between A and B, like you could generate a random number, either 0 or 1, and if it comes up 0, you return A. If it comes up 1, you return B, whatever. You can incorporate that into here if you want to. In the interest of time, I will not. Okay, so let me just finish this off. Okay, so in this case, I shall again arbitrarily decide to return A. A and C have tied. Okay, so here B and C have tied. So in this case, I like going alphabetically. I shall arbitrarily decide that C is the winner. Excuse me, I'll arbitrarily decide that B is the winner. Okay, and finally, in the case that they all tie, I shall just, again, go alphabetically and decide that A is the winner. Okay, so now I return A. Boom. Okay. So what's happening here? You feed the 6 vote totals in. You then compute totals for each candidate. And then based on how those totals shake out, you return either A, B, or C based on who wins. Oh, okay. We ignore that. So to make that guy happy, sorry. Let me just say here that if we tie at the very end, let's just do a catch-all else here that makes it happy. Okay, so way back up here in main, right? Let me now just run this program and let's talk through what happens. So I'm going to choose an election where A is clearly the winner. Let's say that 20 people vote ABC, 20 people vote ACB, right? Then maybe like 5, 5, 6, 6 or something, right? It says, here's your board of winner, A. As we knew it should be, right? This was really skewed towards A. So how did it know that? It knew that because it took those 6 numbers I gave it, like 2020, 6655, or whatever. It then took those 6 numbers, placed them in here in this order, right? The order here matters. And this D value of 20 got put in this A value. So A now has 20. The E value of 20 became B, so B had value 20, etc. So when you're computing these totals here, these totals respect the numbers you gave in main. So this is doing exactly what you did in your homework question, and then based on the vote totals, you just give a winner back, So let's just run this one more time. Let's see if it works if you skew it in somebody else's direction. So poor A gets like no votes, and then B gets a ton of votes, and then C gets relatively few. Your board of winner was B, as it should be, right? B clearly wins this. He gets the most points. Okay, so let me now move on to my last example. So we've done what? Calculating the largest of 3 numbers, calculating a board of winner. Let's finish with a function that tests whether or not a whole number is prime. Okay, so let me clear all of this out. So what would such a function look like? A function that tests whether or not a whole number is prime. Anytime you're trying to determine if something is true, right? Because is prime, that's a statement that can either be true or false. It depends on the number you input. If you input 7, that's true. If you input 8, that's false. So anytime you're testing something like that, testing if something is true or false, that calls for a Boolean function. Is prime. You're just testing a single number, right? Whatever this integer is here, give me true back if it's prime, give me false back if it's not prime. So what you like in main is something like this, like grab a number from a user, and then if that number is prime. So what does that mean? If you give that function the number x, and it comes back as true, so x actually is prime, you could just print prime. Else, you would print not prime. That's how you want it to work in main. But of course, main can't do this now because you haven't told it how this function works. So let me build it now. Okay, so what would this function look like? Well, we can steal again a previous methodology from your homework, from your previous homework, and just recall that if you want to test if a number is prime, you can just go through all of its potential divisors and see if they are divisors using a for loop like this. Okay, so let's just start at 2 because 1 divides anything, right? And let's keep going till we get to n minus 1. Yeah, keep going till we get to n minus 1. And let's just go one at a time. Okay, if the number we are currently at is a divisor of n, okay, so what's happening here? Like, let's say n is 8. Okay, so when this for loop starts at 2, right, 8 percentage 2 is 0. What does that mean? That means you got a divisor hit, which means you are not prime. If you have even a single divisor hit from a loop that's set up like this, that starts at 2 and then ends 1 early, right? So you're not counting 1, you're not counting n, right? That means that a single divisor hit means you're not prime. So if we're not prime, we should return false if that happens, right? So in other words, if this is 8, then as soon as this for loop starts, you've already gotten a divisor hit. Okay, so we should give false back. If, let's say we enter the number 9 right here, right? If that's 9, then when this for loop starts, when I is 2, 9 percentage 2 is not 0, because 9 is not a multiple of 2. So that's fine, you just don't even go into this if block, right? But then I becomes 3, and 9 percentage 3 is indeed 0. So then we would return false. Okay, so the question is, what happens if you make it through that for loop and never get a hit? If you make it through that for loop and never got a hit, that means that you must have been prime. So let me just conclude this example by pointing out the following. If a function ever reaches a return statement, the function just returns that value and then quits immediately. Okay, so this for loop is set to run a bunch of times potentially. Like if n is 8, this for loop I guess should run from 2 through 7, but it won't. If n is 8, then when this for loop starts, you get a hit immediately. You return false and the function just stops, right? You just collapse things. Okay, so let me say that again. Anytime a function encounters a return statement, it doesn't matter what else you've told the function to do, it will return that value and stop. So it's kind of like a break statement inside of a loop, right? No matter what else you've told the loop to do, if you ever encounter a break statement, the loop is over. Same thing with a function. If you ever encounter a return statement, the function is done. Okay, so let me just run this and see if it works. If I enter the number 9, it tells me not prime, right? Because what happens is x takes on value 9. So we come down here, now n is 9. And when you run this for loop, you get a hit when I is 3. So you return false and you're done. Okay, so this is not true, right? 9 is prime. That's not a true statement. If, though, I enter like a 7, that is prime. Okay. So I hope these 3 examples have been helpful and illustrative and all that sort of thing. In the next video, we will actually move on to new concepts with functions. But now we're still just sort of getting our feet wet with the introductory setup of this. Okay, so that's all.